Welcome to Beyond Chips, the Chips GU podcast, where we explore people, projects, and partnerships shaping Europe's semiconductor future. I'm Luciano Gaudio, Head of Communication at Chips Joint Undertaking.
And I'm Vasily Paglidou from the Communications team. Together, we'll be your hosts as we speak with researchers, innovators, and industry leaders behind the technologies powering Europe's digital and green transition.
In every episode, we'll go behind the scene of Chips GU founded projects. We'll hear stories of collaboration, innovation, and real-world impact, from lab to the fab and practical application.
Whether you're part of the Chips GU community or just curious about how semiconductors are quietly transforming everything around us, from farming to mobility, you're in the right place.
Our conversations are guided by a shared principle: clear, respectful, and inclusive communication, just like how we work every day here at the Chips Joint Undertaking.
So let's get started and meet the people behind Europe's chip-powered future. Welcome back to another episode of Beyond Chips. Joining us today, we have Romano Hoofman and Natalia Belova from RETICLES, a project upgrading EUROPRACTICE into a modern European design platform. RETICLES offers SMEs, startups, and academia a one-stop shop for chip design, prototyping, packaging, and training, making advanced microelectronics more accessible. Natalia, can you briefly explain RETICLES and the main vision behind it?
Hello, everyone. Thank you for the question, Vasiliki. So the main mission of RETICLES, in short, is to sustain and extend EUROPRACTICE services. And probably to explain that, I first need to briefly introduce EUROPRACTICE services themselves. This is not a new initiative. EUROPRACTICE started as far back as 1995. Actually, it existed even before that, for 6 years, since 1989, when it was called EuroChip. But today we are celebrating 30 years of EUROPRACTICE services, and we also have more than 600 member institutions, meaning universities and research institutes located primarily in Europe that utilize EUROPRACTICE services. And the big question here, why are they all doing this? Why basically mainly all universities in the region who do serious teaching in microelectronics are using EUROPRACTICE? The short answer is that they're doing this because EUROPRACTICE significantly lowers the barrier to all the services they might need to design and fabricate integrated circuits and systems. And it does it by offering easy and affordable access to three major groups of services. We call them the three pillars of EUROPRACTICE. And here they are. This is easy and affordable access to design tools, fabrication services of different foundries, and training courses and webinars. So, RETICLES project ran for 3 years, since October 2022 until September 2025. And during these 3 years, it was basically sustaining and importantly extending EUROPRACTICE services, adding new technologies and new features in the portfolio.
You have already briefly mentioned a little bit about how RETICLES is expanding on the existing EUROPRACTICE, but I'm wondering if there's anything else that you can share about EUROPRACTICE 2.0 perhaps.
Maybe I can answer that question. So EUROPRACTICE 2.0 actually has a new kind of mission. The mission is actually to connect to the Chips for Europe initiatives. So that means the operations we are doing and the pilot lines, the competence centers and the design platform. So maybe starting with the pilot lines, EUROPRACTICE wants to be an outlet for the service that the pilot lines make to the academic community. So for instance, the PDKs that are being developed in the pilot lines, we want to lower the access barrier for them so that they can try to experiment with those PDKs. So one example is the N2 PDK of the Nano IC pilot line, which we offer already through our platform to the academia, and we complement that with a training service. So we did already, I think, 3 training sessions on site in IMEC, where we are really helping the students, but also the professors to design in gate-all-around technology. Then in addition, what we are doing is reaching out to the competence centers, so to facilitate, I would say, more entrepreneurship at the university level, because of course we have more than 600 research institutes and universities that are making use of EUROPRACTICE. And many of those, of course, create startups, and we want that even more are created because those will feed into the design platform. So there is a very close connection between EUROPRACTICE and the design platform. Actually, you can call EUROPRACTICE the precursor of the design platform because the European Commission saw that EUROPRACTICE was a very essential tool, and not only for supporting the academia, but also to then create later on startups that make use of the services. So that's what we are doing in EUROPRACTICE 2.0.
And about the services that you just mentioned, what kind of specific services are you or will you be offering to the SMEs and those startups?
So traditionally, in I would say the old days of EUROPRACTICE, we were doing the fabrication of chips, so the MPW services for industry and for academia. We were not really differentiating. The only differentiating was that the academia get a discounted price and the industry just paid the normal price in the industry. In EUROPRACTICE 2.0 and also already in RETICLES, we had a concept called the proof of concept licenses. So that were cadence licenses that we can offer to academic spin-outs. Now, of course, with the European design platform or chip design platform, we are now working very closely together to also, I would say, launch that principle for the other design tool vendors. And as I said, we see a very close collaboration between EUROPRACTICE and the design platform on this area. And then the last part, the last pillar of EUROPRACTICE is training. So we will also develop more and more training courses that can also be given to the industry. So that's what EUROPRACTICE does for startups and SMEs.
That's fantastic. So it sounds like there is an overall support for SMEs, startups, and also students in academia, because what is also important is to engage these younger generations and try to decrease and minimize as much as possible the talent shortage as well.
So this is basically how we see our mission now. So EUROPRACTICE and EuroCDP, the EU Chips Design Platform, we will provide complementary services. So EUROPRACTICE will be focusing on European academia, while the EU Chips Design Platform will be focusing on startups and SMEs. So this way, we will provide a clear path from research to the market.
And is there any specific support for academia and students in gaining access to these advanced technologies?
Oh, yes. Here we have actually several initiatives in EUROPRACTICE. First of all, we have a special program, you can call it. It is mini-ASIC solutions. So how do we actually bring down fabrication costs? Let's take a step back to explain what mini-ASIC is. We do it by offering multi-project wafer or MPW services when basically designs from different users are fabricated on the same wafer. This allows to share mass costs and wafer fabrication costs between different users. And basically we have particularly small MPW blocks that we call mini ASICs. And these particularly small MPW blocks, they are, of course, very important for very small nodes for advanced technologies, meaning that universities and research institutes can prototype in advanced technologies cheaper. And on top of that, we also have a special program called TSMC University FinFET program. IMEC, the coordinator of EUROPRACTICE, they are part of this program that was launched by TSMC itself. And through these programs, universities that are EUROPRACTICE members in Europe can gain more affordable access to N16 and N7 technologies of TSMC. It is especially beneficial for the N16 technology because for it also the access procedure facilitated, meaning that the approval process is easier and goes smoother than before. And through this program, we already had 40 universities who signed NDAs and engaged with designing in FinFET technologies. And 4 first universities from Europe prototyped in the N7 technology of TSMC last year. And all in all, we see that it is very fruitful because the number of designs in FinFET technologies fabricated through EUROPRACTICE has doubled compared to what we had at the very start of RETICLES project 3 years ago. And we also have initiatives to motivate users to move to advanced technologies. So during RETICLES, 113 users used advanced technologies for the first time. And by advanced here, I mean technologies with a node less than 28 nanometers. So between 28 down to 5. And also 69 long-term users of EUROPRACTICE services were motivated to make a design in a smaller node compared to what they were using before.
And can you share an example, perhaps, of a success story from an early user?
Well, actually, I would like to first give a few examples of success stories of users that we have already since the beginning. So one example is ETH Zurich, who has been using EUROPRACTICE from the start of EUROPRACTICE. And they have a platform that they call Pulp. And Pulp is a RISC-V platform that they have advanced through the different prototypes that they have manufactured through EUROPRACTICE. So this is clearly a success story. And then in addition, I would like to mention CERN, so the Nuclear Accelerator Center in Switzerland and France, who are having a program where they do IP exchange. So they have many universities and research institutes who are designing for the new accelerators in Switzerland. And yeah, they are really working very closely together. So they are exchanging designs with each other, exchanging IP with each other. So this is also a very good success story to share here. But maybe Natalia can give a success story from a first user from industry.
Yes, of course. So EUROPRACTICE, as we said, supports mainly European academia, but we also can provide support to academic spin-outs. And such a success story, we always like to talk about it because it is very representative. It is a company called Deep Detection. They are a spin-out of the Autonomous University of Barcelona. And they developed and brought to the market new generation of X-ray cameras for industrial inspections. So basically in these cameras, they combine advantages of different technologies such as X-ray and photon counting. And this allows them to detect foreign objects and contaminations during industrial inspections much better than if you use X-ray alone, for instance. So Deep Detection, they actually started with the proof of concept program with us that Romano previously mentioned. Through the proof of concept program, they accessed design tools. They could be used for non-commercial purposes, but later when they were ready to bring their product to the market, there was a commercialization fee. And basically this delay lends a hand to early stage spin-outs and gives them a substantial support because, as you know, at the early stages of their existence, funding tends to be more limited. So after using the design tools through the proof of concept, they also accessed MPW fabrication services through EUROPRACTICE, so they could create the first prototypes of their cameras to convince their investors. And later on, they also moved on to volume production. And it's important to mention that volume production is not part of EUROPRACTICE services. We say that our users graduate from EUROPRACTICE when they move to volume. But we can, of course, point out the route, how they can proceed towards those services. And in the future, of course, this is where we will hand over users to the EU chips design platform. So here we will also be working together. So Deep Detection is a great example of an academic startup that successfully made the whole journey from the very beginning, from the academic design to the market, together with EUROPRACTICE services.
So with all these success stories and positive feedback that you're collecting, I imagine it's not all smooth. Have you encountered any technical or operational challenges in offering such a broad range of services?
Yeah, so maybe first I explain a bit how broad the range of services is. So if you look to the design tools, we have at least more than 10 vendors who we are distributing all the different design tool licenses. So I think in total it's more than 10 or maybe even more than 20,000. I don't know the exact number. Licenses that we are distributing to the 600 universities and research institutions.
65,000 design tool licenses distributed.
I was even underestimating the whole number. If you look to foundries, it is more than 20 foundries where we are giving access to the universities for prototyping. And we are managing this by, I would say, even distribution over the different partners. So as you know, we have only 5 partners who are in the RETICLES and a EUROPRACTICE 2.0 project. So we have IMEC as the coordinator, STFC in the UK, CMP in Grenoble in France, Fraunhofer in Germany, and then Tyndall in Ireland. And what we do is that STFC is focusing mostly on training, but the most effort goes actually in the distribution of the design tool licenses. And Natalia already mentioned this, so many that, of course, you can imagine this is a big task to manage. And then if you look to the different foundries, there are also many MPWs need to be executed for the different universities. There we have divided it over the different partners. But indeed, there are also challenges. The biggest challenge actually is that we are handling more and more complex advanced technologies. And you need also to have the right people. Maybe the biggest challenge is to find those people who can manage the tape out. Yeah, because of course you can imagine if you make a mistake, then the customer is not happy because he will get a chip back that is not functional. So we need to make sure that we provide really the best support that we can so that the user will also have a functional chip later on his desk.
I have only a few more questions. And one of them is, how does Reticles contribute to Europe's competitiveness and sovereignty in microelectronics design?
As Romano already mentioned, we have a very large technology portfolio. So we provide access to more than 100 technologies of 22 different foundries and technology suppliers. And importantly, 19 of them have manufacturing facilities in Europe. This means that we do not only support European academia, we also support European suppliers because thanks to EUROPRACTICE, they can reach more users. And our portfolio includes, for instance, technologies of large European manufacturers such as ST Microelectronics and XFAB, but we also have smaller European RTOs, including EMEC itself, CLAT in France, IHB in Germany. And I must mention that IHB today is being very popular. In our MPW statistics, actually, it has the third largest share by the number of designs prototyped through EUROPRACTICE. And it has the third place after the two giants like TSMC and Global Foundries, which is a very impressive achievement for a European RTO. If we are talking about design tools, we have big players in our portfolio. Of course, Cadence, Siemens, Synopsys, they provide their tools to European academia through EUROPRACTICE. But here again, importantly, we also support European design tool vendors, such as, for instance, MZ Technologies or Monotsukuri. It's a European company, and they manufacture design tools for 3D integration. Also, how else do we support Europe's competitiveness? Of course, the biggest answer here probably is by training the next generation of engineers. So as Romano already mentioned, a very important group of EUROPRACTICE services together with design tools and fabrication, it is training. And during Reticles project, we delivered 96 training courses. And these training courses are very comprehensive. They usually last from 2 to 5 days. They include the theoretical sessions and importantly, the hands-on part. So if users do not know exactly how to start designing using a certain design tool that we offer or using a certain technology and they need to be brought up to speed, these courses are a perfect place for them to start. And these courses had more than 4,200 participants during the 3 years of Reticles. We are very proud of this number, and we are also very proud that more than 260 professors and university lecturers also attended these training courses. This means that when they came back to their auditoria, they passed on their newly acquired skills to their students, basically increasing our reach manifold.
You're right to be proud. So really, I have to congratulate you for your efforts.
Thank you.
I wanted to know what was the difference that the CHIPS JU funding has made in Reticles. Perhaps it has allowed you to upscale your services or reach even more users.
Well, if we talk about CHIPS JU funding and how useful it's been, first of all, EUROPRACTICE can play such a key role for European academia because we can keep our services affordable and easily accessible to all the 600 plus members. And we can only do this thanks to the European funding, because without it, we would need to drastically raise the prices of our services and they would become available and accessible only to a handful of very wealthy universities in the European region. And of course, we want to avoid it. We want to keep this access as democratic and as low as possible. Also, without this funding, we wouldn't be able to keep the formidable portfolio that we have. Without the funding, we would need to shrink this portfolio to only a few most popular solutions. And of course, all this would negatively impact fundamental research and education in the semiconductor domain in Europe. This is why we had the RETICLES project from Chips to You, and this is why, thankfully, we will also have the next project called EUROPRACTICE 2.0.
But Chips EU can do more, together with the support of the European Commission. So I want to give you the example of Taiwan. Taiwan has a similar initiative as EUROPRACTICE. It's called TSRI, so it's the Taiwan Semiconductor Research Institute. They do 2,000 tape-outs by academics per year, while we have less than 600 for the European users or the European academic community. How do they achieve that 2,000 number with a much smaller number of academics? They do that because the tape-outs are actually subsidized or are fully paid by the Taiwanese government. So I think what Europe could do is to reserve money and I would say fund those tape-outs for the universities in Europe. Because what we see is that many universities don't do a tape-out because they simply don't have the money. And also, I would say in the current way that money is distributed, also it becomes more and more complex for universities to do such a tape-out. So there are all kind of public procurement and tendering schemes they need to follow. So also the number of paperwork that needs to be done is really horrendous, I would say. Sorry for that word. So there, I think that the European Commission and Chips EU can really step in and try to boost that number because that's important for the future of Europe.
You're right. Paperwork can really be a burden. And what can be difficult as well is for these entities, for academia to find even perhaps the opportunities to apply for them. Just before we close, I have only one last question. What long-term impact do you expect RETICLES to have on European innovation ecosystems?
I think the long-term impact will really come of the very close connection between EUROPRACTICE and the design platform. So EUROPRACTICE will really upskill the trained workforce for, I would say, the future companies that we will have in Europe. So fabless companies who will make new chips that are going to change our future. But we also want that there will be one or maybe two unicorns. So maybe the next NVIDIA or another company that is really going to change the world. And that's something we really will have to do together with the design platform. So as I said earlier, in EUROPRACTICE, we will train the engineers. But of course, we should stimulate that young people create a startup and that those startups are then creating chips in the design platform. And that's something where really EUROPRACTICE and the design platform go hand in hand.
Collaboration is at the heart of the CHIPS joint undertaking. Thank you very much, both of you, for your time and for the lovely discussion.
Thank you.
Thank you very much.